This demo shows the ability of Calibre InRoute to perform Signoff Litho simulation within the Olympus SoC layout environment. Litho simulation is performed with Calibre LFD to detect layout constructs which are prone to significant distortion when printed on silicon and thus can cause yield and reliability degradation. The design is placed and routed on 45nm technology. It has about 80,000 routable nets. This is Olympus GUI. In this demo we will use the layout window, command window below where I type commands and see log messages, and error browser. We will use it to examine LFD violations. Design has already passed DRC sign-off with InRoute built-in Calibre DRC verification, which is shown in a separate demo. Now we want to run Calibre LFD or Litho simulation to detect layout constructs which make the design less manufacturing friendly. LFD analysis simulates layout contours under many different combinations of light intensity and defocus to reproduce how the silicon contours will look. We will perform live analysis for a small section of the design. Let's first configure the built-in Calibre LFD run. Configuration process is similar to that of Calibre DRC and other embedded Calibre applications in InRoute. Command is config Calibre LFD. Now we will launch LFD analysis confined to the layout window currently visible in the GUI. Check LFD -mode Calibre -window. There are only two major LFD violation types, width and spacing. They are also sometimes called necking and bridging. There is one width violation in this layout section. Let's see the process variability bands to understand why this piece of wire was marked as a violation. Blue contours mark the process variability band or PV band as it's simulated by LFD analysis. The PV band captures the complete process window variation for a particular edge. In other words, for the given set of simulated optical conditions, deviation of light focus and intensity from nominal values, the actual wire edge can be found anywhere between these lines. The biggest distortions typically occur near to the edges of the adjacent shapes, due to the interference coming from adjacent apertures in the mask. As you can see, for worst conditions, wire is predicted to be dangerously thin. Now we will use InRoute Search and Repair Router in LFD mode to repair LFD violations detected by Calibre LFD analysis. Router attempts to move aggressor shapes away from the violated areas as gently as possible to minimize perturbance to the layout. As you can see, it has moved one of the aggressor wires by only half the pitch. Because Calibre is in the inner loop of the router, it can check the changes and the results are Calibre clean. Just to prove it though, we can run another LFD analysis to verify it. As you can see, there are no LFD violations anymore and no new violations were created, so the fixes are convergent. Let's take a look at process variability band. When we look at the same location, we can see that the width degradation is much milder than before. So in this demo we showed how Calibre InRoute detected vulnerable constructs in a DRC clean layout using built-in Calibre LFD. Then we used InRoute Olympus router to perform automatic repair of the identified violations. The designer can now guarantee that the design is Calibre LFD clean without ever leaving the Olympus place and route environment, and also without having to understand too much about the Litho issues faced at that particular node. This makes reaching manufacturing sign-off much simpler and faster than previously possible.